Wright Tool's 97-year legacy of forging America's toughest sockets relies on machines, materials, and manufacturing secrets that most competitors abandoned decades ago. While other manufacturers like Snap-on moved production overseas or switched to casting methods, this Barberton, Ohio factory still operates the same hot forging processes that built the Hoover Dam and powers NASA's space missions today. Walk into the Wright Tool factory, and you are stepping into nearly a century of American manufacturing history. Founded in 1927 by C. Nelson Wright, who started by selling tools from the trunk of his car, this company has grown into something remarkable. They forge sockets with openings up to 10 inches and drives reaching 3½ inches. Massive tools, normally driven by hydraulic power, that can generate up to 8,000 foot-pounds of torque. Size isn't what makes Wright special, though. It's their unwavering commitment to a process that most manufacturers abandoned decades ago. While competitors like Proto Tools turned to casting, machining, or overseas production, Wright doubled down on hot forging, specifically closed die forging, the most demanding and expensive way to make a socket, but also the strongest. The secret starts with their material choice. AISI 4140 chrome-molybdenum alloy steel. This isn't your typical hardware store metal. This chromium-molybdenum series steel delivers exceptional fatigue strength, impact resistance, and toughness that standard carbon steel simply can't match. When properly heat-treated, 4140 achieves a hardness of 54 to 59 on the Rockwell C scale, hard enough to bite into the toughest fasteners without chipping or cracking. The transformation from raw steel bar to finished socket begins in Wright's forging department, where temperatures reach 1,200 to 1,300 degrees Celsius. That's over 2,300 degrees Fahrenheit, hot enough to make steel glow like the sun. High-power induction coils heat the steel bar in less than 60 seconds. Then it's descaled with rollers and sheared into precise blanks. What happens next is where Wright's expertise truly shines. The glowing steel blank moves through multiple forging stages using machines with names that sound like industrial poetry: the die forger, hot forge upsetter, and drop hammer. Each machine shapes the steel differently, gradually transforming a simple cylinder into the complex geometry of a socket. The upset forging process is particularly crucial. This technique compresses and shapes the heated steel under tremendous pressure, creating what's called grain flow, the internal structure that gives forged tools their legendary strength. Unlike machined or cast sockets, where the metal grain runs randomly or gets cut, hot forging aligns the grain to follow the socket's contours, creating natural reinforcement exactly where stress concentrations occur. Gary, one of Wright's master machine operators, has spent decades perfecting the timing and pressure required for each forging operation. "You can feel when it's right," he explains, monitoring the massive presses that shape each socket. The knowledge he possesses, the subtle variations in temperature, timing, and pressure that separate good sockets from exceptional ones, represents decades of accumulated expertise that can't be programmed into a computer or shipped overseas. After the initial forging, the rough socket shape moves to the broaching department. This is where Wright creates the precise hexagonal or 12-point openings that grip fasteners. Broaching uses a specialized cutting tool that looks like an elongated saw, but with teeth that progressively increase in size along its length. The broach is pushed or pulled through the socket opening, with each tooth removing a tiny amount of material until the final tooth creates the exact dimensions required for SAE and metric standards. The broaching process requires incredible precision. Wright operates both inner and outer broaching machines, creating not just the socket opening, but also the external drive connection. The tolerances are measured in thousandths of an inch. Any deviation and the socket won't properly engage fasteners or connect to impact wrenches, ratchets, and drive handles. Once broached, the sockets undergo Wright's proprietary heat treatment process. This isn't simply heating and cooling, it's a carefully controlled metallurgical transformation. The sockets are heated to precisely 845 degrees Celsius, transforming the steel's crystal structure from austenite to prepare for the critical quenching phase. The quenching process happens incredibly fast. The red-hot steel plunges into oil and cools hundreds of degrees in seconds. This rapid cooling traps the carbon atoms in the steel's crystal lattice, forming martensite, the hard, wear-resistant crystal structure that allows Wright sockets to grip damaged fasteners that would strip lesser tools. Hardness alone isn't enough, though. Steel that's too hard becomes brittle and can shatter under impact. That's why Wright follows quenching with a tempering process, reheating the hardened sockets to a lower temperature that reduces brittleness while maintaining strength. This balancing act between hardness and toughness is what separates professional-grade tools from hardware store alternatives. Steve Hathaway, Wright's maintenance supervisor with 40 years of experience, understands every nuance of these heat-treating furnaces. He's seen how small variations in temperature or timing can affect the final product, and his knowledge ensures consistent quality across thousands of sockets produced each month under their ISO-certified manufacturing processes. After heat treatment comes finishing. Many Wright sockets receive chrome plating, which provides more than just corrosion resistance. The chrome plating process involves electroplating a thin layer of chromium onto the steel surface, creating a mirror-like finish that not only looks professional, but also reduces friction and makes the sockets easier to clean. Quality control at Wright goes beyond visual inspection. Nancy Dalton, quality control supervisor for 4 decades, oversees testing that includes hardness verification, dimensional checking, and torque testing. Every batch of sockets undergoes rigorous testing to ensure they meet or exceed ASME standards and Wright's own internal specifications. The company's confidence in their process shows in their warranty, lifetime coverage against defects in materials and workmanship. As Terry Taylor, Wright's chairman recently inducted into Barberton's Walk of Fame, puts it, "You don't just hand someone a Wright tool, you pass it down the line." This philosophy extends beyond marketing speak. Wright's patented Wright Drive technology, protected under U.S. Patent 10,442,059 B2, distributes contact force over a larger surface area, reducing the stress concentration that causes inferior sockets to round off fastener corners. Their precision-engineered contact points grip fasteners more securely while applying less pressure to any single point. The manufacturing process concludes with marking and packaging. Wright has maintained date coding on their sockets since 1940, originally using 2-digit years and switching to alphabetic codes starting with A for 1961. This traceability allows the company to track production batches and provides collectors and users with manufacturing history. From raw steel bar to finished socket, the entire process takes place under one roof in Barberton, Ohio. Wright's commitment to domestic manufacturing means they control every variable, from material sourcing to final inspection. When they guarantee 98% of products will ship within 36 hours, they're not relying on overseas suppliers or complex logistics chains. The markets Wright serves reveal the critical nature of their products. These aren't tools for weekend garage projects. They're used in oil refineries, power plants, wind turbines, and NASA space programs. When a socket failure could shut down a power plant or compromise a space mission, Wright's uncompromising approach to manufacturing makes perfect sense. Today's Wright tool continues the vision C. Nelson Wright established nearly a century ago. The same building in Barberton houses the same commitment to hot forging, the same attention to metallurgy, and the same pride in American manufacturing. In an era when good enough often drives business decisions, Wright Tool proves that perfect remains worth pursuing. As Pat, one of Wright's longtime leaders, tells every new employee, "Don't let me down." It's a simple phrase that captures the weight of responsibility each worker carries, not just to their employer, but to the professionals whose lives and livelihoods depend on tools that never fail when failure isn't an option.